Today, you should be looking at your journal and recording in the table of contents, page 75 to 76. We'll be doing lesson 3 today as we continue our journey into geometry. Whoops, excuse me. So we're going to do sum of angles in triangles. So the sum of angles in triangles, and that's going to be our lesson today, which is, of course, lesson 8-3, and we'll be talking about the sum of angles in triangles. So you're going to be turning right now to page 75 in your journal. Hopefully you're keeping up with us. 75 is actually found on the right-hand side of your journal page. So just make sure that when you get done today that you are going on page 75 and then flipping over and putting the second page on page 76. So sum of the angles in triangles. So this is page 1. This is where your notes, and again, this should be page 75, and then we'll be doing page 76 on the continuation page, and these will be going in separately. And if you want to, because this page is kind of short, if you decide you want to cut and trim this out and glue it in so it doesn't have to be folded, you're welcome to do that as well. So we're going to first talk about how we get the sum of angles in a triangle. So our first examples here is to talk about different types of triangles. And you've learned about angles in previous vocabulary that we studied, like what is an acute angle, what is a right angle, what's an obtuse. So when you're looking at triangles, we know the word tri means that there are 3 angles, and that's hence the name of the word, triangles, meaning 3 angles involved. And it takes 3 line segments and 3 vertices to create a triangle. So you're going to always have 3 vertices. And just like on angles, angles are named by 3 points. But if you were to connect those 2 points, so you notice there's an angle here, if you were to connect those 2 outer points, then that would create our 3rd line with our 3rd vertice. So we have 3 vertices going on here. So we have a vertex here, a vertex here, a vertex. So there's actually literally 3 angle measures creating that triangle, and each of them has a measurement. Okay, and we're also going to talk about side lengths that are congruent side lengths and how that classifies triangles. Every triangle in the world has, and I have it right here, 2 names. Just like you have a first and a last name, triangles have a first and a last name as well. Their first name, we generally speaking talk about their angle measures. So we'll describe the angles first, and then their last name is by using their sides. So just like I always tell you guys, don't go just by your first name on your paper, because that's what 5-year-olds do. We want to be more specific. So instead of when you were 5, you called it a triangle. That was a triangle. Now we're going to get specific. What kind of triangle? It's got a first name and a last name. And really kind of technically, I guess it's a first, middle, last name if you really want to think of it that way, but we won't go there. So we're taking a look at the angles here. And it says all of these are acute. So this angle measure we know to be less than 90 degrees. The one over here on the bottom right is less than 90 degrees. The one up here at the top is less than 90 degrees. If all 3 are acute, then you know it's an acute triangle. So that's just the first name for this triangle. Then we talk about its side lengths. So here's the exact same triangle down here. And we take a look at it, we say, let's look at it. Now, it might be hard to tell, so you might have to rotate your page a little bit to see that the angles are a little different, and that makes the side lengths different. So angle measures actually determine how big the side lengths or how long the side lengths are. So if I put my notepad inside and I can kind of see, we definitely know that's an acute. It's less than 90 degrees. And we definitely know that's acute. We definitely know that's acute. But I can take a piece of paper, and you get a piece of paper on the STAR test. You actually can have an index card too. And you could actually mark it. So that's the length of that side. And then if I compare it to this side, I go, oops, that one's different. Yeah, I bet you weren't guessing that that would be that much shorter. And then when I go over here to do this side, I say, whoa, that's different as well. So we've got 3 different measures. So in the world of geometry, we say, I'll put 1 mark, and it doesn't matter where I start. I'll put 1 mark there to show that that length is not the same as this length here, okay? And so when I do that, I'm putting an extra tick mark, and that tells me they're not the same, they're not congruent. And then down here, I'm going to put 3 marks, which means that that side length is different than both of these other two. So we use these tick marks to help us with congruency. So because none of the sides are the same and none are congruent, we call this scaling. Now, how to remember that? Well, think of the scales on a fish. And if you've never seen a fish, like a bass or any kind of fish, they have different size scales. So around their eyes, they have these itty bitty little round circle scales. And then as the scales get further away from the eyes towards the body of the fish, the scales get bigger and bigger. So scaling, hence the word scale, think fish. All the scales are different sizes. So all the side lengths are different sides. So this is called scaling. Scaling. So these triangles are identical. So its first name is acute, its last name is scaling, acute, scaling, and that's the name for that triangle. So take a look at the next triangle. I have a right triangle, and I know that because there's a right angle right here. So you're saying, well, how many other angles do I have? Well, this angle is acute, this angle is acute. They're both measuring less than 90 degrees. Just a reminder, it doesn't matter which way they open, and if you're having a hard time telling if it's acute, you can always rotate the page and see that this is still measuring less than 90 degrees. And again, you can use the corner of a piece of paper or a notepad or whatever you have. And if you use that corner, you can tell that that angle measure is less than 90. But this is not called acute because it takes all 3 of the acute triangles to be an acute triangle. This has one right angle with 2 acute ones. It doesn't matter that these are acute. You can't have an obtuse with a right angle, and we'll talk about that in a minute. So this is a right triangle. Now, if you notice, the same drawing wasn't down here, so not identical. This is not a right triangle. Right triangles do have other names, so I'm going to go ahead and mark this. I know that this length is different than this length. It's pretty obvious. And I know that this length, which is actually going to be called the hypotenuse, which you'll get into next year. Hypotenuse is only on right triangles. That's different length. And since all 3 are different, this is right scaling. So I'm just going to put the last name on here. It is right scaling. So you know that the angles do determine it, but the side lengths give it the last name. So this is right scaling. And I'll put it right there, right scaling. This one is acute scaling. And this one also is acute scaling since we already talked about it. So let's take a look at this one down here. So notice it's got the 2 tick marks. It's telling you that these 2 sides are the same. That means this one's different. Now I call this my little Fu Manchu. See, he's got little eyes and a little goatee here. And I know that this is going to be called isosceles. Now the reason why it's called isosceles, according to the sides, and this is how you remember it, you see the SOS, 2 sides are the same, and then one's different. It's an odd. So 2 sides the same. This is S, this is S, this is O. SOS. This is an isosceles triangle. Now that's its last name, isosceles. What's its first name? Well, you take a look at the angles and you say, well, that's less than 90 degrees. That's less than 90 degrees. That's less than 90 degrees. Oh, and by the way, this angle is the same as this angle. And the reason why is that when they open up, they create the side opposite that angle. So this angle created that length. This opening created that length. And because these sides are the same or congruent, their angles are also congruent. So if you notice, I put tick marks there, 1 and 1. This angle is different. This angle is actually smaller because it creates a smaller side length. So hopefully that makes sense. So if you take a look over here, this angle was created by this side right here opposite, or creates this side length, excuse me. So this angle opens up and it creates this distance here. So that means if you take a look, this side is actually shorter than this side. That means this angle measure is shorter than this one here because this angle creates this side length opposite it. So it's little things to think about. So I would put a 1 mark here because it goes with that side. They're not measuring the same, but they go together. I put 2 marks on this angle measure because it kind of goes with that. But just because this is 90 degrees doesn't make that length 90. That's not really the correlation. It just means that this length is determined by this 90-degree opening. We'll get into some things in 8th grade that talk about right triangles as well. So this is isosceles. And because all three angles are acute, 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 acute. If you say acute, acute, acute 3 times, it's an acute triangle for sure. If you say right, there's a right angle, it's a right triangle for sure. So this is acute, acute isosceles. Isosceles, say that 3 times. Isosceles, isosceles, isosceles. Kind of sounds like you say isosceles, but no. All right, let's take a look at this triangle over here. Obtuse angle. This angle right here measures more than a 90-degree angle opening. It's opening like that. It goes past 90 degrees. We know this is obtuse. So because I have one obtuse angle, and again, this angle creates this length, which is really long. I'm going to call that length 3. This angle over here creates this length right here. And that looks like the shortest side. I'll make that a 1. And this angle here creates this length over here, and I'll make that a 2. And so we're going to call this an obtuse triangle for sure. It only takes one obtuse angle. And we'll talk about why you can't have more than one obtuse. And that's obtuse triangle. So let's talk about the side lengths. So this is 1, this is 2, this is 3. All of them are different lengths. We would call this scalene for sure. So this is obtuse, always by the angle first, and then scalene by the side lengths. So talk about the angles, talk about the sides, and you've got the 2 names of the triangle. Now this is the only triangle that exists that only has to have one name. For example, a square is a square. Okay, it has 4 sides all the same length, 4 right angles. It's called a square. In this case, on the triangle, it's called an equilateral triangle. You don't have to put a second name because equilateral implies that everything is equal, the angles and the side lengths. So if this angle and this angle, I'm sorry, if this side and this side and this side are the same, that means the angles that are opposite. So this side is created by this angle. This side here is created by that angle. This angle creates that side length there. If they're all the same marks, that means they measure all the same measure. So equilateral triangle, you can say acute because all the angles are less than 90 degrees, but it is not necessary. So the 2 names are acute equilateral, but honestly, you don't need that word. Just say equilateral. It means everything is equal, angles and side lengths. So I want to talk about for a minute what happens with angles in a triangle. And so I have for you guys cut out a little triangle here. And I'm going to take this triangle and I want you to take a look at it kind of carefully. So for just a minute, take a look at it. And I rotated it just a little bit so you can see. Do you recognize this angle measure? If you don't, you can take the corner of the notepad that I used to create it and stick it inside. And if you notice, it fits perfectly. This is a right triangle. Most of the time they'll tell you it's right, but if you don't know, take a piece of paper in the corner and see if it measures 90 degrees. Now this is a right triangle. It definitely looks like all the sides are different lengths. Yep, scalene. So it is a right scalene triangle. But here's what I wanted to do. Okay, so this was this angle measure here. This is this angle measure here. And we know this is shorter than this one. And you don't need to put this in your journal. I just want to show you. I am going to rip off this angle here. Okay, I ripped off that angle. I'm going to rip off this angle. And I'm trying not to tear it straight. And I'm going to rip off this third one. So I have basically just mutilated this poor triangle. I'm going to take these 3 angle measures. And it doesn't matter what order I put them in. I'm going to take the angles, those were the angles of the triangle, and I'm going to put them all 3 together. So if you take a look, I just put all 3 angles together. And I don't know if you noticed this or not, but they create a straight line. So we talked about angles all together in your vocabulary cards and your vocabulary terms, that when all 3 angles add up to a straight angle or 180 degrees, these are supplementary angles. They all add up to 180 degrees. That's where this comes in. It doesn't matter what triangle it is. Looking at that triangle, it's 180 degrees. Let me take this triangle right here. So this triangle right here, if you take a look at it, it is obtuse. That measures more than 90 degrees. And it's also scalene as well. So another obtuse scalene triangle. I'm going to take all three angles of this triangle. There's one. There's two. There's three. And I'm going to put all of these three angles again together, just like I did on this last example. And I'm going to put them all together. So if I slide, whoops, if I slide all of these pieces that I just ripped off together, and it's kind of hard to tell because it's buckling up, but it should add up to, and I just need that side to come down a little bit. All three of these angles add up to 180 degrees, a straight line. So that tells me that no matter what the triangle is, if I tear off each of these three corners and I lay them out, they will make a straight line. So I want you to write this down at the bottom. So right here below, all angles of any triangle equals 180 degrees. Now I told you where this would come into play. All angles of any triangle in the world equals 180 degrees. So that means the sum of this example, this angle plus this angle plus this angle equals 180 degrees. Well, all three of these angles are the same. So if I call this angle X and I call this angle X and I call this angle X because they're all X's and they're all the same, that means that 3 X's or all 3 X's equals 180 degrees. So to find the value of 1x, I'm simply dividing the 180 into 3 equal parts, evenly distributing it. And 3 goes into 18 6 times. That means each angle is a 60-degree angle. And on an equilateral triangle, it is always, always, always 60 degrees, 60 degrees, 60 degrees every single time. Now the side lengths can change. So if this side is 10, this side's 10, and this side's 10. If this side's 26, that side's 26, that's 26. But the 60 degrees does not change. The length of the sides can. So that's going to help us later. So take a look at the figure here, and we're going to name it. It says the triangle has 3 acute angles. Do you agree? That's acute. That's 20 degrees, I told you. This is acute, that's acute. And if you notice, if I turn him this way, he looks like our little triangle guy. I put a Fu Manchu on it because these two sides are the same. The third one must be different. Then I know this to be my SOS, isosceles. Okay, so back over here. It has 2 sides the same length. That means it's isosceles. And the first name would be acute. So acute, isosceles, all angles are less than 90 degrees. And 2 sides are the same. SOS, 2 sides same, isosceles. Okay, you're going to have to learn that one. We're going to move over to page 75 now. You're going to glue that last one in when you're done with the notes. And this is where we're going to name them. So we're going to take a look and we're going to say, oh, okay. Now this one's kind of hard to tell. So I take a piece of paper or a corner of a paper and I shove it inside and I say, does it match exactly? Okay. And oh, there you go. You can tell it does. So we're going to put a right angle in this and we're going to say, okay, first name is right angle. So we talked about the angles. Then we're going to talk about its sides. So I take a look at its sides and I say, and if you don't know, you can take out your notepad and start measuring. But I think you can start to see if you turn the page just a little bit, look at it in different directions, that all the sides are different. So this is 1, this is 2, this is 3, and you might have done 1, 2, 3, or you might have done 1, 2, 3, it doesn't matter. So this is right. And remember the scales on a fish, all different lengths. This is right scaling. That's the 2 names for that triangle. Number 2, it's got a right angle, so we're going to call it a right triangle for sure. And again, this side is shorter than this side, and this side's different. So again, a right scaling. So we gave you 2 of them. So this one was tricky because you had to actually put a piece of paper in there. This one's very faint to see, but if you notice, it's got all 3 the marks the same. This is not Fu Manchu. This is all 3 sides are the same length. That means all angles are the exact same measure. We would call this an equilateral triangle. I am not going to put acute because it only needs one name. That's the special one. It's kind of like having a Madonna. There's only one name. This one has 2 marks the same. That means these 2 sides are the same. That means this side's different. And as you can tell, we have our 2 sides the same with a different angle coming off of this one over here. SOS stands for isosceles. And if you take a look at the angles, this is a really large angle here. So we call that obtuse. It only takes one obtuse angle. And here's why you can't have more than one. If this measures 100 degrees, can I have another 100 degrees? Well, 100 plus 100 is 200, which exceeds the 180 degrees that the 3 angles have to add up to. Same thing with a right triangle. You can't have more than one 90-degree angle because 90 plus 90 is 180. That's only 2 angles, and you can't have 2 angles on a triangle. You have to have 3. So this is obtuse isosceles. So you'll be naming triangles in the classwork. And then the last thing you're going to be doing is solving for unknown values based on the fact that you know that all 3 angles have to equal 180 degrees. And if it doesn't, you've done something wrong. So I know that this angle is 2x. I'm going to write it down. Let's start with my variable first. And then you can go to this one or this one. It doesn't matter. Order doesn't matter because addition order doesn't matter. 2x plus 40 plus 90. And you might have done 2x plus 90 plus 40 or 40 plus 90 plus 2x, but it has to equal 180 degrees. Don't worry about the degree sign. It's not as important. Now, we haven't talked about this before in solving algebra, but normally you'd say, okay, minus 40, minus 40. But what you probably want to do is combine these 2 units together because they can be combined. So 40 plus 90 is 130. And all I did was just combine these 2 numbers together. And you don't have to put parentheses around them. Now I'm going to subtract the 130 from both sides. And it's going to leave me with 50. And I'm going to get rid of this. And I'm 2x is equals 50. So what's the value of 1x? So x equals half of 50 or 25. Think of money. Half of 50 cents is 25 cents. So x equals 25 is my solution. And I'm done. Take a look at number 6. I know that 5x, that's this angle, plus my 20-degree angle, plus my 25-degree angle has to equal 180 degrees. So add my 20 and my 25 together to get 45. So just combining those 2 together equals 180. And then I'm going to subtract 45 from both sides. Just a reminder, you have to borrow from the 8 here, make it a 7. That's a 5, a 3, and a 1. And that equals, and these cancel out, 5x. And then I divide by 5 on both sides. So 5 into 135, and I do a little quick math over here. 5 goes into 13 twice is 10. I get 35. It goes 7 times to make 35. I get 27 as my answer. Last problem. This one has an obtuse angle. I'm going to start with the x though. 4x plus the 130 plus the 30. And again, it doesn't matter what order you go in. Do 4x plus 30 plus 130 or 130 plus 30 plus 4x. I'm just trying to keep my variable up front. It doesn't matter. That has to equal 180 degrees. So the sum of all 3 angles of a triangle must be 180. And you've got to know that fact. Learn it. So I've got 4x is 130 and 30 make 160. That equals 180. Subtract 160 from both sides. I get 20. 4x's is 20, divide by 4. And x equals 5. And I'm done. All right, glue those notes in. I think you're going to have a great time working with angles on triangles. I'll see you next time.